just do the final construction, okay? So this is just the hard one. Okay. So we have a circle, yeah? Yeah. We have the center of the circle. We have some point D on it. Yeah. This is C, yeah? And we have some point like B over here. Okay. Right. And let's for simplicity, I mean there's also like another point here, right? But let's just, for example, say we have these 3 points and focus on them, okay?
Okay.
And then we want this point here. So if we draw a line, so it passes through the center of the circle. So that's the hard part, yeah?
Yeah.
The line passing through center, okay? And we're trying to construct the line, or at least the point of intersection, without a ruler, okay? So if we had a ruler, we'd be able to draw the line and then get that point of intersection. If we don't have a ruler, we have to use some compasses, okay? Some compasses to get this point here, okay? Okay, let's go. So before we drew a circle for B to reflect D here, yeah? Right?
Yeah.
I'm not going to draw the circle. So that's all we need it for, really, yeah? So put the D here, yeah? D prime. So it's just a reflection, yeah? Okay. Then, do you remember we drew a parallelogram, yeah? So we have this D, right? We made a parallelogram. With F, yeah?
Yeah.
You remember that?
Mm-hmm.
Okay. And so this is D prime F, D prime C F, yeah?
Yeah.
Parallelogram. So the way we got that was because we knew we could draw circles. So you might want to watch the other part of this, yeah? We could draw a circle centered C with radius D prime, yeah?
Yeah.
And we could draw a circle centered D with radius the same as this radius, yeah? Well, that you could do that anyway, right? So then the intersection of those circles will give you an F, yeah?
Yeah.
Okay. I don't know if you need this, but this definitely helped me. Is this fact about parallelograms? Okay. So do you know that for a parallelogram, the sum of squares of diagonals is equals sum of squares of sides? Yeah? Okay, you guys should know this.
Oh, yeah.
So this was a Geometry Revisit Chapter 3 exercise, yeah?
Oh, that equivalence. Yeah, okay.
Yeah?
Yeah.
Remember that?
Yeah.
Okay. Alright, stop talking about Brawl Stars. We'll finish early, we can have a dedicated Brawl Stars chat. Yeah, David says da, so we're assuming this now, okay? Da.
Yeah.
Okay. Okay, and we do the same thing on the other side here, right? Yeah? Ooh, is an F prime. F prime. Now do the same thing on this side now, okay?
Wait, I think David said that to people play Brawl Stars.
Okay. Okay. Okay, so we draw another parallelogram on the other side, yeah?
Mm-hmm.
C, D prime, F prime, yeah?
Mm-hmm.
Remember that?
Yeah.
Let's do the same thing, yeah? Yeah? You want to make this distance the same as the radius, and this one is d prime, yeah? So you got two parallelograms, yeah? So this is something we were trying to say last time, but there were too many damn circles, okay? So CF, right, okay, is parallel to d prime, yeah?
Yeah.
CF prime is also parallel to d prime, yeah? So that it's a straight line.
That's like what I said before. But
Yeah.
then, like,
Okay, so it's important.
Parallelogram.
Okay. So it's a straight line, yeah?
Mm-hmm.
Not only is it a straight line, it's perpendicular to the dotted line, yeah?
It's a reflection.
Yeah? It's a perpendicular. Because D is perpendicular, right?
See, it was symmetric.
Yeah, it's symmetric. Yeah. Okay, then now we're ready to almost finish this, okay? So I need another... maybe I don't care about erasing this. It'll be so... Okay, so now, remember how we drew it? We drew a F prime D length to there, yeah? Yeah. Gonna do this with the black. Yeah. Remember we got M. Yeah. We got the intersection of F prime D and F D prime up here. Yeah.
Yeah.
Yeah. So that's one of the diagonals of the parallelogram, isn't it?
Yeah.
F prime D is the diagonal of the parallelogram, isn't it?
Uh-huh.
Yeah.
Yeah.
Okay. So let's think about the distance now. Like, what's the distance? So what's this point here? Let's just call it X, yeah? What's the distance? What's the distance? I guess at this point we don't care about the original point B anymore, yeah? Not really. Okay, so can you see that the distance from the center to X, right, is the same as the length of one of the sides of the parallelogram, right?
Yeah.
Okay. And the distance from the center to M, okay, is, Pythagoras, yeah? Okay, so let's have this Cm squared, yeah? Okay, Cm squared plus what are you gonna say? This is called Cf prime, yeah? Yeah? Is equal to F prime M, yeah?
Yeah.
Okay. Does that make sense? Okay. But look at what the distance between F and X is, yeah? Fx squared, yeah? Is equal to Cf squared, yeah? Plus Cx squared, right?
CX squared is equal to.
Just CD squared, yeah?
Yeah.
CX squared, yeah? So let's collect the terms in a way that's really easy to organize, yeah? So let's use black. So FC is the long side of the parallelogram. It's called let's call it B, yeah? And the short side is called A, yeah?
Yeah.
Okay, so let's convert these equations. So you have, let's call the diagonals C and diagonals, we're going to call it X and Y. Let's call it diagonals. So the short diagonal, let's call it, well, the short diagonal is just A, right? Yeah?
Right. What FD prime is A?
Yeah, the long diagonal is B. Yeah, the long diagonal is, let's call the long diagonal, so long diagonal is F prime M, yeah? So we can call that like Y, yeah?
Okay.
Or we can make it capital A or something, yeah? Does that make sense?
Yeah.
So the short diagonal is just A, right? Because the radius.
Yeah.
Yeah? Okay, so what does this equation become? Cm squared is... Okay, well let's not say it. So here we have just Cm squared, right? Is equal to Y squared minus Cf prime squared, yeah?
B squared.
So it's B squared, yeah?
Yeah.
Okay, what's this one here? Fx squared.
Fx squared.
Yeah, so Fx squared equals Cf, so that's B squared, right? Yeah?
Cx, which is A. Plus A squared.
Plus A squared, yeah?
Yeah.
Okay. And what does this tell us, yeah? It tells us
that
Y
that.
squared
Oh.
plus
Whoa.
A squared, yeah?
Yeah.
Equals 2A squared, 2B squared, yeah?
Whoa.
So Y squared
Equals A squared plus 2B.
equals A squared plus 2B squared.
Wow.
You guys got that already? Yeah. This is equal to Y squared minus B squared, right?
Yeah.
Which is equal to Cm squared, right?
Yeah. Wow.
And so we just need to now make the radius equal to Cm and draw a circle about F.
Yeah. Yeah.
Oh my gosh. Are there any questions about that? Yeah, it's kind of funny. It's like the bridge between sort of junior, intermediate, and senior. So that's like the end of all the stuff that doesn't need inversion. But it was also the stuff that we got stuck on when we did inversion. Yeah, so I basically got this by staring at that JPEG file I sent you
Oh, that's it.
while waiting for my son to fall asleep.
It's a PNG. Right? How do you pronounce PNG?
Oh yeah, PNG file. Alright.
Is this something you found or something you made?
Huh?
The photo.
Oh no, the photos from Wikipedia, sorry.
Oh.
Yeah. Actually, it was funny. I was looking up YouTube and seeing if someone already had like a video talking about it, so I could just copy it.
Yes.
But it was funny because like someone had the same subject matter, and then I look at the comments, and this guy's like, "But you forgot the case when it's collinear with the center." And I'm like, "Ha ha ha." and then the guy's like, "What's the deal, man? You could have so easily looked this up.
Yes.
You could have looked it up on the Wikipedia article, which I wrote. Apparently, the guy in the comments wrote that article, and he was like an undergrad at the time. But this was a while ago. But yeah, So you think you can just edit a Wikipedia article, huh?
Yeah.
You get credit for it? No, you don't.
It depends on my show up.
It doesn't?
Exactly.
Okay. Okay, guys, any questions? Does that make sense?